Hello friends, welcome back. So today we are going to solve one problem on queuing theory, and let us understand how to solve a queuing theory. So here is the problem. In this problem they've given you arrival rate and the service rate. Now what they are saying is the arrival rate of a customer at a bank counter follows Poisson distribution with mean of 45 per hour, and they have also given the service rate of the counter follows Poisson distribution with mean 60 per hour. Now they've asked you what is the probability of having 0 customers in the system, and also they have asked you find LS, LQ, WS and WQ. Now here when you are this question, what they have asked is there is a bank. Now how do customers arrive at a bank? How many customers arrive at a bank? So they have given you the arrival rate of customer at a bank. For an hour, 45 customers arrive. Now that is called as 45 customers per hour, and at that rate, that is called as arrival rate of the customer to the bank. Now how fast they give you the service at the bank? That is called as service rate. In an hour, they're serving 60 per hour, 60 customers per hour. That is the service rate. Remember guys, they have given you service rate. Your thing will change if they are given you service time. If they are giving you service time, then it is different. Now they have asked you is service rate. Right? Now arrival rate is nothing but it is your lambda. Right? Now service rate is nothing but it is your mu. Right? If they give you service time per customer, then that is different. I will tell you what to do if they give you service time. So things will change. So don't get confused with service rate and service time. So clearly it is given as service rate. Service time is different, service rate is different. Service rate is mu, service time I will tell you what to do. Okay. Also, they have asked you to find out the probability of having 0 customers in the systems. 0 customers means what? 0 customers means the service provider is free, or you can say he is idle. What is the denotation for that? The denotation is P naught. Now we need to see the formula of calculating P naught. That will give you actually the probability of having 0 customers in the system. Means service provider is free or idle. So if we find out this, we will get the thing to do. Right. Anyway, and the second point what they've asked is you to find out LS, LQ, WS and WQ. Right. Now quickly we'll go to the problem and we'll start solving it. Alright. In this problem, they've given you two important things. First one is arrival rate. What is arrival rate? With what rate the customers are coming to some service is called arrival rate. What is rate? Why don't we say just arrival? Arrival means just he comes. Arrival rate means how many customer comes in some time. This rate is always reference to some time. whenever there is time associated with some arrival or some service, then you call it as a rate, service rate, arrival rate. Now in this particular problem, there is a bank. There is a bank. And to this bank, how many customers are coming per hour or per day or per half day, something like that. How many customers are arriving? Arriving means how many customers are coming to the bank, or how many customers are coming to the barber shop, how many customers are coming to the supermarket, how many customers are coming to the telephone booth. That is the arrival rate. This arrival rate is denoted by lambda. Now, the second thing what they have given you is service rate. When somebody comes to the service, maybe here in this case it is a bank. It can be a bank, it can be a shop, it can be a haircutting salon, it can be a petrol bunk, it can be a highway toll plaza, anything. Okay. Now, at what rate customers are coming? What rate the vehicles are coming? That is arrival rate. Now, service rate. Second thing is service rate. How fast the people sitting here are giving service to the customers. Now, that is called as service rate. Now, service rate is denoted by mu. How to write mu? Mu is nothing but in the cursive handwriting, if you write M, it is similar like that, but the first leg is little bit longer than the second one. So you write mu something like this. Now the lambda is something like this. You should write it. Okay. So anyway, so here we are discussing what is a service rate and what is the arrival rate. Now in this problem, they have given you the arrival rate and the service rate. Right? So anyway, what is the arrival rate? The arrival rate is 45 customers per hour. Okay, it is 45 customers per hour. Now, what is the service rate? Is, how much is it? 60 customers they are able to service. 60 customers per hour. Okay. Now, what we have is this thing. All right. Now, since they have asked you arrival rate and service rate, you can easily move on. First thing what you need to check here is both arrival rate and service rate should be on the same parameter. Here also it is measured in hour, here also it is measured in hour. If here it is measured in minutes, here in hours, then you should balance them. You should take either one of them on the same platform, right? Or let's say arrival rate is in days, this is in hours. Then also things change. So you need to basically find out whether, both are on the same platform or no, right? So now lambda is equal to 45 per hour. I'm not going to write it because it is 45. Then we have also got mu is equal to 60. Alright. Now once we have this, so sometimes in some problems they will give you arrival rate, but they will not give you service rate. They will give you service time. Service time is different from service rate. What is service time? Sometimes in other ways they'll give you. It takes 3 minutes to serve one customer. If it takes 3 minutes to serve one customer, then that is not called as service rate. How much time you are spending per customer, that is service time. But how many customers you are serving for an hour or for one day, for 30 minutes, that is service rate. If they give you service time, you have to convert. That is not mu. This is not equal to mu. Service time is not mu. In fact, if they give you service time, your service time will be mu is equal to 1 divided by service time. Okay. Now, if that is into minutes and converted into hours, then it has to be into 60. If it has to be converted into minutes. If it is in days, 60 into again how many hours? 60 minutes is equal to 1 hour and 24 hours is equal to 1 day. If it is in day. Now it is not in day. If it is in minutes, then you are converting like this. So just for your example, I am giving you what to do when service time is given. But in this particular problem, it is very straightforward. They are given you arrival rate and the service rate. Clear? So anyway, I'm going to take this off. Now quickly solve the problem. It's a very simple, straightforward problem. Now what they've asked you is, the first question is, they've asked you what is the probability of having 0 customers. As I told you, 0 customers is nothing, means the service provider is free or he is sitting idle. He is sitting with no job. There is one formula, there is one notation to find out idle time. What is that? Yes, it is P naught. To find out P naught is equal to 1 minus rho. You need to find out. So P naught is equal to 1 minus rho. You need to find out rho first. How to find out rho? So you are solving the first one, A. So to find out rho is nothing but the traffic intensity. There are several names for it. You can say traffic intensity or service intensity or utility factor. It is also called as utility factor. You make better notes of this because in examination they might ask you to find out traffic intensity, they might ask you to find out service intensity or utility factor, or they might ask you something related to utility something. So these are the keywords wherein you can find out. All are one and the same. So traffic intensity is the most common thing what they use. Is nothing but the rho. What is the formula to this? Is called as rho. Now rho is equal to, what is the formula? Lambda divided by mu. Lambda divided by mu is 0. 45 divided by 60. So I'll better take a scientific calculator. And if you calculate this, it is 0.75. Sorry, 0.75. Yes, this is rho. Now next thing what you need is the idle time. That is probability of having 0 customers. Probability of having 0 customers you need to write. Therefore, probability of having 0 customers is P naught is equal to 1 minus rho is equal to 1 minus 0.75. If you do this, it is 0.25. If you convert this into percentage, it is 25%. Means 25% of the times, the bank employees are sitting idle. Means they're actually free, having 0 customers. But 75% of the time, they're always busy. So, you got it? Right. Busy is nothing but this traffic intensity. It is the traffic intensity or the utility factor. They are busy, right? So first one, we have solved this, right? So what is the second question? They have asked you straightforwardly to find out LS, LQ, WS and WQ. All right. Okay. Right. So what we have now is lambda is equal to 45, mu is equal to 60, then we have rho is equal to 0.75. Now B, what they have asked us is to find out LQ. LQ is equal to rho square divided by 1 minus rho. That is 0.75 whole square, square divided by 1 minus 0.75. The answer, when you do the mathematics here, alright, 0.75 whole square divided by 1 minus 0.75. This is nothing but 0.5625. This is equal to 2.25. Alright, 2.25 is the first answer. Now, the second thing, this LQ, I hope you people remember from the theory, LQ is the length of the queue outside the system. Okay. Now, they have also asked you to find out LS. LS is rho divided by 1 minus rho. Rho is 0.75 divided by 1 minus 0.75 is equal to, so 0.75 divided by 0.25 is equal to 3. Right? So the next thing what they've asked us to find out is WQ. So actually it was first WS, LQ, LS, LQ, and WS and WQ. So I'll take up WS then. 1 divided by mu minus lambda, 1 divided by mu is 60 minus 45, 1 divided by 15, is equal to 0.06 is the WS. Then the last one what they've asked you is WQ, that is rho divided by mu minus lambda. Rho is 0.75 divided by 60 minus 45 is equal to 0.75 divided by 15, that is 0.05. Yeah. So now you have found out the P naught and all that was A. P naught you got, that is 0.25. In B, they have asked you LS, LQ, WS, and WQ. You have found all of these things. So LQ is length of the queue outside the system, length of the queue inside the system, waiting time inside the system, waiting time outside the system. These two are related, these two are related. You know? So this is the straightforward question wherein you can solve the queuing problems like this. So we will solve the next problem in the next video. Thank you.